Perfect. All right. Thanks for confirmation. Looks like we're up and running. So thank you for joining. Thank you, everybody. I appreciate your time. Today, I want to talk about refining your API, specifically when we talk about API design and dealing with that last mile of API design, how we can make our API designs better, more effective, deliver higher quality APIs for our consumers, and how to go about doing that along the way, especially toward the end. So if you're already in the process of designing an API, it's already in flight, but you have a little bit of time to make some improvements. What kind of things can you do to address that? Or if you're just starting out, what kind of approaches can you take to ensure that you have a great API design? So just a quick introduction about myself. I'm a consultant that works with a lot of organizations globally. I primarily consult to enterprise IT, but also work with some software as a service organizations that are a little bit more mature and in a growth stage. I am based in Colorado Springs, and I do a lot of speaking. Like today, I also do API training, API design training. I work with organizations to help them establish, grow, and mature their API programs. So it's a combination of training, consulting, and of course, being an author on the Principles of Web API Design book. So a lot of the things that I'm going to talk about today are kind of teasers to the book and expanding upon what is in the book already. So first thing that I want to do is have a conversation about conversations. I don't know how many people might take this kind of position, but in my opinion, APIs are really a conversation, and they're a conversation at three different levels or three different styles of conversation. The first is machine to machine, and this is where we spend most of our time. If we had an interaction between client and server saying, the client asks, can you give me a list of projects that I'm allowed to see? And the server says, sure, here's the list of projects you can see. And then the client says, well, can you create a new project for me? And here's the name for it. It's called My Project. And the server says, yep, okay, you sent me everything I need. Done. Here it is. Here's where you can find this new project resource that we just created. And the client then says, well, can you send me the details for project number 1, 2, 3, 4, 5? I know it is my project. Can you give me the latest details about it? And it says, sure, here are the details for you. We're having a machine to machine conversation here. And we can think of it almost like SMS text messages. But really, what we do is we have all these HTTP requests and responses in a traditional REST environment. And likewise, in GraphQL and gRPC, we might see something similar. So in this case, we might see a get to slash projects, and then we get a 200 OK, and we get some JSON, and then we post to projects to create a new one if we're following our REST CRUD patterns. And we get a 201 created, and we get a location, and then we get that project by ID and get the latest representation of that resource. And those are the machine to machine conversations. We spend a lot of time doing that as technologists. We love this kind of stuff. This is what excites us, or at least excites me, when we think about designing APIs. What's it going to look like? What's the developer interaction here, and so on? What are the resources? What are my operations? So on and so forth. That's the first conversation. Unfortunately, that's where our conversation ends in a lot of cases. The conversation ends with the machine to machine, and we forget there's two other conversations going on. One other conversation that we have is developer to developer. This is where we build reference documentation, getting started guides. Our job here is to help developers use our API. And unless you are building an API specifically for a team within your organization that can reach out to you via Slack or Teams or whatnot, or walk to the same or another building on a campus and ask you a question about the API, this conversation happens not in real time, but in a more self-service manner or asynchronous manner. We're going to give some development docs to a developer, and our hope is that the docs are sufficient enough to help that consumer understand how to use our API and get things done that they're trying to get done. So that can include reference documentation, examples, step-by-step recipes of how to use the API to get things done, getting started guides on how to onboard, get your API token set up, all of those kinds of details. So that's the second conversation, developer to developer. The third, and what I believe is really the most important, even beyond that, is the human to human. When we design an API, we're helping people get things done. Ultimately, they have a problem and they want to solve that problem in some way. Either they're trying to communicate with someone or they're trying to organize themselves, they're trying to do something. So in this case, maybe an example would be a homeowner asking a project manager, can you tell me where we stand? What's the current status of my home remodeling project? And the project manager says, sure, here are the tasks completed, the items remaining, and the budget details. Are we over or under? Where have we spent the most money? If we start with these conversations, our APIs are going to be a lot richer. They're not going to be as anemic where we're just grabbing data out of a database and shuttling it across the network. Instead, what we're going to do is we're going to start thinking about what is the problem or the thing that's being asked, and how can we solve that problem or answer that question. So we have those three conversations: machine to machine, developer to developer, and human to human. And all of those factor into our API design. If we take a step back a little bit further on the human to human, we really are having conversations across a digital organization. Whether you have a software as a service or your enterprise IT, you have different conversations that are going on, from public app developers to customers to your internal developers, your workforce, your staff, and your partners that you have. You're all having conversations. And oftentimes those conversations are interacting with APIs, or at least that's what a lot of organizations are striving for. They're trying to target an API first mindset where they're taking the way that their business works and digitizing the different aspects of that so that it can be either automated or at least interactions can be digital, less manual, and more interesting and effective. So to do that, a lot of organizations I'm working with are shifting the conversation away from just pure data APIs to delivering outcomes. And we're doing that through a technique that I'm going to introduce a little bit later of how to go about that when you're designing your APIs. The first thing that we have to do, though, is recognize that we, in every organization, have IT capabilities. That's our systems, our data, our processes, and so on. The expertise that we've built in-house, the expertise that we're outsourcing to people that have that knowledge and are bringing that in. And then the business capabilities, where our organization is delivering some sort of market need to that marketplace, and they have certain business objectives and the business capabilities they've built up to meet that market need and to be profitable or to be effective in some way. And unfortunately, what we end up seeing in a lot of these organizations is that they take their data sources and their legacy systems and they design an API that just delivers that data. And that's it. They just purely deliver data, and they're what I would call an anemic API. It doesn't really bring with it a lot of capabilities, a lot of operations that are robust. We're just moving data around. And there are times when we just need that raw data. But most often, we're trying to have a conversation with someone, a human, a machine, somebody, and there's more to it than just the raw data. So what we really have to start thinking about is how do we bring our IT and business capabilities together and deliver on these outcomes? And when we think about refining our APIs, this is where it's really, really important to be able to know how we're approaching the intersection between what our business delivers or what our nonprofit delivers into the marketplace and what IT capabilities we have, and pull all those things together into what might be called a platform set of capabilities or domain capabilities or digital capabilities, however you want to think about that. There's different terms in different organizations. Whatever the case is, we would be leveraging the insights we have about market needs, our business capabilities that we have today. What's our operating model? How do we work? How do we do business internally? And then how does that integrate with the marketplace, with our customers, with our partners? And bringing that together with our IT capabilities to deliver a set of platform or digital capabilities that help get things done. And so what it does is it starts to drive a higher level of conversation. Our platform starts to produce digital outcomes that our humans need, that we know that our machines need to be able to interact together. So what I see in a lot of organizations today is everybody's kind of taken that shift to microservices. And from that perspective, everybody, oftentimes executives down, say, we're going microservices. And what I think they really mean or intend is we want to think a bit smaller than we used to. We want to have smaller units, smaller areas. And that's where our domain-driven design, our bounded context, all of these things come into play to help us kind of organize and deliver these types of capabilities in smaller units, and we might further decompose those into microservices. But what I oftentimes see is that organizations start kind of in a code first. Let's build the services, and then we'll produce something from that. And it misses the opportunity to have the effective conversations that we need to have. So as API producers, we need to have conversations with the humans to find out what are they really trying to do so that we can deliver the right solution. We need to have conversations with the developers to find out, is our API design helping to support that need that we just built? And so when we think about all these elements and put them together, we have to reach beyond just breaking things into service and thinking about code purely and start to think about productization or product thinking, taking an outside in perspective on our API design. And that allows us to deliver outcomes to the marketplace, to power our workforce internally, to be able to orchestrate and manage all of the processes that we have today and the processes we'll introduce in the future. So we have to start bringing these things together, and that platform area in the middle that I'm talking about is where all of that comes together. Our services, our APIs, everything come together, and our platforms focus on delivering stability and reuse, and they can be packaged and bundled together into digital products that address particular market segments, needs of internal workforce or partners or customers, and so on. So we have to start bringing in a lot more product thinking as we start to move forward with our API designs, and particularly when we're starting to refine them. So if we start off by taking a product thinking approach, then we're going to be in good shape to deliver an API that's going to support those kinds of conversations that we have. If we haven't, and we have an API already, then maybe there's some other things we can do to get there. So let's kind of talk a little bit about what that looks like. When we think about our microservices, those are kind of the machine to machine conversations. When we think about the platform, that's really developer to developer. How are we bringing all of our APIs together to allow other developers to create and solve new things and automate things? And we have the product side of human to human. So when we look at those aspects and think about those conversations, we can refine our API design to then meet those needs. And that will allow us to improve the quality of our API. So when I talk about API quality, what do I mean by that? Well, a lot of people might have, different definitions of it. These are just 5 things that I want to talk about today. There's definitely more to it. There's some things you can qualitatively measure, or quantitatively measure, or might be related more qualitatively to the types of interactions we have with our developers. But primarily, these 5 things, we want to make sure we're aligned to the needs of the API consumer, not the producer. So we're going to optimize for the tens to thousands to potentially hundreds of thousands of API consumers that we might have along the way, not to the one team that's building one code base to deliver APIs. Oftentimes see a lot of optimization made for, instead of the consumer, for the producer, for reducing the amount of work that it takes to build the API, but they push that work over to the consumer and make it harder for the consumer. So we don't want to do that. The next is to map out our business processes, not just the raw data. We want to incorporate security from the start. We want to bring in outside-in design rather than a code-first approach. And we want to make sure that we test our API design with feedback, so we can involve the testing cycle, not just with automated testing, but with putting our API design to the test with feedback early and often before we have to write a lot of that code and then refactor and produce a lot of potential technical debt, or however we want to think about it. Lots of follow-up work that we have to do to improve things, because we had to scramble and make the last minute changes to our code base to accommodate changes in our API design. All of these things require conversations. And so that's what we're going to talk about a little bit. One of the things I like to do to align to the needs of the consumer rather than to the producer is to start with something called job stories. Job stories were built by Alan Clement, and he used the jobs to be done framework from Clayton Christensen, who wrote about that years ago in some of his books. The idea of the job to be done is, if you're building a startup or delivering some sort of service or product, that product or service is being hired to solve a problem. So how do we identify the problems that your company provides, or your particular solution, or in this case, your API? What kind of problems does it solve? And so job stories give us kind of a format that's similar to user stories, but they focus on 3 specific elements: the problem or triggering situation. What is the current situation where we need a job to be performed? The last part is the outcome desired? What is the final stage? So if we know what the problem is, and we know what the end result or the end condition or final solution needs to be, then we figure out what's in the middle. That's the digital capability or that job to be done. So in this case, we have this job story. When I can't recall my password for an account that I've logged into successfully in the past, I want to reset my password to something new so I can log in successfully to the application once again. Now, this is a pretty trivial example, and obviously we could have things that are a little bit more broad and coarse grained that really talk about the marketplace a little bit, but this gives you an idea of what a job story looks like. And what it allows us to do is find what is that job to be done or that digital capability we need to build. And then do we need one or multiple APIs and API operations to deliver that outcome, to get from that problem to the outcome? So when we think about delivering to the needs of the consumer, it means stepping back and not looking at what systems do we have? Are we using AWS, Google Cloud? Are we going to be doing serverless? Are we going to build out microservices? Are we going to be doing, some sort of event-driven architecture? That's important, and it's going to come later. But the first thing we need to do is check ourselves and say, do we know what success means? Do we know what our acceptance tests need to look like? And these job stories give us a foundation for our acceptance tests. If we can't deliver on this job story, we failed to deliver all the necessary elements to produce that outcome desired. So we missed that conversation that's happening human to human, and we failed to solve the human problem because we focus so much on the technical solution area that we have. The next thing that we have to do is start mapping our business processes and not just raw data. Now, I know earlier there was a discussion, there was a talk on domain storytelling, which is a great way to do it. Then storming is a way to do it. There's different ways to do it, but taking those job stories, we can break those things down into either diagrams or text-based narratives of what are the steps that it's required to get from the problem to the solution. And those activity steps help us to find the operations for our API. It helps us understand what our APIs need to do. And it gives us a good blueprint for how we can break these things iteratively into smaller delivery chunks to get feedback, to make adjustments and changes, to be truly agile, not to follow a big A agile process, to be small a agile and responsive to the needs of the people we're building the software for, which was the whole purpose of agile back when the manifesto was released around 2000 or so. So the idea here is mapping your business processes to support what the humans need. Now, if we just start with the business processes, we're keeping the end user out of the equation. We're not having the human to human conversation. We're more like developer to developer. We're thinking about solutioning and things like that. So we want to kind of lay this out, but we want to do it in a way that maps back to the job stories so that we know what our outcomes are. We know what the needs are of the end user, and then we can deliver APIs that meet those needs. Notice I haven't talked about microservices yet. There's a reason for that. Now, as we go along further, we can start taking those activities, map them into different API operations. We can figure out who's going to be using those operations, and that gives us a hint as to API security needs. Gives us at least a first pass of who's allowed to use what operation. Is everybody allowed to call each operation of my API, or do I need to have some finer grained controls and so on and so forth? What does it look like? And then, as we're mapping this out, we can also capture things like events that we might have meant. So if we think about webhooks, WebSockets, server-sent events, or perhaps message streams that are internal to the organization, what are those events that we might want to capture and collect and analyze or react to whenever this operation is executed successfully or unsuccessfully? So when we start mapping these things out, we start figuring out what's our API security, what authorization requirements do we have, and we start thinking about that earlier rather than later in the API design process. And then once we do that, and we're taking this outside-in approach, and we're taking this design approach first rather than code first, it allows us to find our resources. It allows us to map that API profile where we have all of the different operations into a particular API style, whether it's REST or GraphQL or gRPC. It allows us to find all these different resources and their relationships to kind of start mapping out some of the properties that are there. And, we can pull all these things together so that our API design is a little bit more thoughtful. This is where we can get really valuable input before we start writing the code of what is our ubiquitous language. What vocabulary does this particular area use? Have we settled on the right names for things, so that when we jump into our IDEs and we start writing code, we know what we need to call things. The naming work has been done, and it's been done because we've paired up with experts from the domain. We've gathered information from our subject matter experts, and we pulled all those things together to represent what that world is, what that solution space is. And that's really, really important. Once we have all those design elements pulled together, we want to test our API design. And rather than writing code and then waiting, making everybody wait, including front end developers that are waiting for your API to be built out so they can integrate it with the screens they've built already, we can mock things up. So we can use API sequence diagrams like what you see on the left to kind of show the interaction of the operations. We could use Markdown or some other format like what you see on the right to mimic HTTP request and response interactions. Here, what we're trying to do is not deliver reference documentation like OpenAPI specification does, or like you would be familiar with JavaDoc and other kinds of documentation where we see each operation in its details. This is showing the collaboration of the different operations as they interact with each other to take you from the problem of the job story to the solution. So we're trying to show how our API gets someone from the problem to the solution. In other words, acting as that job or solving that job to be done, acting as that solution to it, that digital capability. And so when we think about API design, it's more than just all the HTTP methods and response codes and JSON structures. It's about that human to human aspect of what's their problem, what's the solution, how do we get there, and to easily and repeatedly be able to break that down and to be able to get it to the point where we can quickly arrive at an API design, put it in front of somebody, some of our initial consumers, and make sure that it solves the problem. And if we do things like this, this is it's really the beginning of an acceptance test is what you see. It's either a diagram that shows the sequence of events for a particular scenario, or it's maybe some markdown that is the beginning of a getting started guide that you'll hand to the consumers to say, here's how you use my API. This is how I intended it. But they get to see it before you've spent a lot of time building out all the code, give you feedback. You can incorporate that feedback and move forward. Now, it doesn't mean that you can't start coding at all. There's oftentimes technical risks we need to deal with or infrastructure details we have to get stood up and things like that. But what we want to do is try to avoid a big bang coding event that the design is not known until the code is done, in which case it's so costly to be able to make any changes to the design that we either have to push out a design that's suboptimal or we have to scramble to quickly rip our code apart and change it around to get it to meet the needs of our consumers because we failed to talk to them early and often. So all of this goes back to the human to human, the developer to developer, and ultimately to the machine to machine of what our design needs to do. So all of this ties into what's called the ADDR API design process. ADDR stands for align, define, design, and refine. Those are the 4 phases we go through. The align phase, we're seeking stakeholder alignment. We want to make sure we understand what the humans need so that we know that we're going to build the right thing. Define allows us to take those insights and turn it into a wireframe of what our API needs to do. That wireframe can then be translated in the design phase into a REST API, gRPC API, GraphQL API, or maybe a combination of those things. The refine is where once we've done this quick work, where we've not taken the expensive route of building a lot of code, but rather we've taken the lightweight route of putting these things together in a tabular format just to be able to message and get feedback, then we can put this in front of some of our consumers. We can refine and improve our API design. And then from there, we can ultimately be able to make the changes, start to code, document our APIs, and we're documenting an API that we have confidence in that's going to solve the needs of the consumers and ultimately of the humans that are going to be using this API through a web or mobile app, or maybe solving some machine-to-machine automation scenario. And we can make sure that it's going to take care of all those problems. And if it doesn't, we can go back and we can revisit the design a little bit, incorporate the feedback before we spend a lot of time writing a lot of YAML or using our documentation helper tools like Stoplight and other types of tools, API Wiz and others, to document our API and build the open API spec, and then having to go make a lot of changes to the YAML to achieve the design changes that we need based on our feedback. We can iterate fast, make changes, get it where it needs to be. Then we can start building out the documentation, building out the code, and everything else. And then we go into our standard delivery and manage process where we build it out, iterate over it, and we can slice it into different slices, preferably vertical slices that go from front to back, and so on and so forth. So all of that to say that when the align phase, when we're dealing with the align phase, we're talking about human to human. Define phase is involving human to human, and it's transitioning to the developer. We have the machine to machine aspect that's in the design phase. And remember, we talked about how oftentimes we start with the machine to machine and we miss all of these other opportunities. And then when we refine, we're getting the developer to developer aspect brought in as well. So that's a lot of information. But what I wanted to talk about here is when we think about refining your API design, we need to align to the needs of our consumer, not our producer, map our business processes, incorporate security early and often, take an outside in design and refrain from diving straight into the code or the solutioning, and to test our API design with feedback. And you can, if you're in the middle of an API or if you have an existing API, you can do this in a brownfield scenario. You can go find and determine what that job story is, and then walk through and see how your API measures up to deliver that job story, and see, have you identified any gaps that you might have missed, or are there opportunities to optimize the design further? Now, one other final thing that I want to do once we, before we go into Q&A, is to talk about a bit about microservices. There's been a lot of chatter, funny enough, on Twitter and other social media because of brouhaha from the Prime Video team and some other stuff coming up with, here's what we did and here's what we changed things. And I think all of us here can probably reason out and say there's no one silver bullet or single path of architectural decisions and patterns and that we want to use, that everything is context dependent. But as a warning, I see a lot of organizations when I go in there think that they're building microservices with the traditional Lego or Duplo envisioning. But what they end up doing is they build a bunch of microservices that are fragile. And if you take one away, or if you move one or slightly shift one around a little bit, everything comes tumbling down. And so, unfortunately, we see a lot of organizations with the right intent falling behind. And so what we end up seeing are these, traditional Death Star diagrams of dependencies and services calling services and so on and so forth. And what that does is it increases the coordination costs. Why is that? Because what happens is we have our API consumer calling an API that maybe calls a service, calls another service, calls another service. We didn't mean to get that way, but we started from our service perspective and eventually built an API instead of starting from our API and building out our services. And so what we didn't do is measure the cost of having failure from service to service to service as we chain calls. And I see call chaining, which to me is an anti-pattern, happen a lot. And, we can put in service meshes and all kinds of fancy technology to try to solve that. But ultimately, we have 3 levels of coordination we have to deal with. We have to coordinate the network traffic and failure coordination. That's where a lot of people put in service meshes to solve that problem. We have deployment and change management coordination. So every time a service changes, we got to kind of coordinate that service change with everybody else, because if B changes, it could impact A, and there might be others as well. And so we have to figure out who owns everything and talk to them. And then what happens if there is a failure and we can't complete the request successfully? We have a coordination and communication problem where we need to error message back to the end user. So our API has to be smart enough to give an error message sufficient enough that our API consumer can figure out what's going on. So we have this machine to machine coordination, developer to developer, and human to human, all kinds of communication and coordination that happens. I won't spend too much time on this, but Uber actually wrote this up on this article. Many of you might have seen this already, or it might have been referenced earlier today, but they kind of felt that pain. They figured out that their services were too fine grained. They were too granular. And so it required touching a lot of different services and open up code from them to get everything to work. And they create the networked or distributed monolith that had to coordinate deployment and everything else. I lived through the SOA days. Some of you may have as well. We saw that often. We had ESBs and we had code in our ESBs. And we had to coordinate that with our SOAP services that were deployed and all kinds of other stuff. And it was a nightmare. And then we had middleware like API gateways that we have today to enforce security and do all kinds of transformations and things. We had to coordinate with those. Sometimes those were an ESP, sometimes those were another vendor yet again. So all of it is about coordination. And so if we're not careful, we can break things up so small that we introduce way too much coordination. So Laura McGuire wrote about this in an ACM article. She said controlling the cost of coordination will continue to be an important issue as systems scale, speeds increase, and the complexity rises in the problems faced. So what she's really drawing out here is the more complex that things become, the more coordination is required. And so the more distributed components that we introduce, the more coordination we might have if we can't get our boundaries right. And so that's really what I see a lot when people start not with the outside in, not with the job stories first, and then work their way back to a solution on the back end that can support that. But they start with, oh, I envision 10 microservices here, this one, this one, this one, and this one. And we really don't know how all those things are going to come together. So finally, the ADDR process, what it helps you do is it helps you to design that API, and using things like API sequence diagrams or other things, you can spot those areas where if you introduce a service, where is there going to be a network call? And is that network call valuable? Does it hinder the API? Is it going to introduce a problem? Or is it actually going to solve a problem? So if you have an existing API and you're trying to figure out what to do, reverse engineer what you're doing into a sequence of operations like this. Find your job stories, figure out what you have, find your gaps, and find ways to refine your API. Then look for opportunities to introduce services where it makes sense, finding where your boundaries are at, if the boundaries are too fine-grained or coarse-grained, if you're going to introduce way too many API calls over the network, chaining things together and causing a lot of problems. So just keep in mind, every time we depend on another team for a service, a code, or an API, we slow down to wait on them. We have to have meetings to coordinate with them. The goal of microservices is really to reduce coordination between teams by creating that independence. But to do that, we have to really think about proper software architectural principles and practices and apply these design techniques so we can catch these things pretty early. So, ask yourself, are your architectural and design decisions increasing or decreasing your coordination costs? Are they making things easier or more fragile? So that's it. I've got my book is here. There's a short link here, a bit.ly link to that. We have the ADDR process. It's got 7 steps. It's across these 4 phases: align, define, design, and refine. That's what ADDR stands for. And you can use that to design and get feedback and deliver on your API design successfully. So I'm going to leave it there and open it up to Q&A. Hopefully this has been valuable to you, and I'd love to chat with you with any questions you might have.
Thank you so much, James. And thanks for getting up so early today to making this possible. Would be lovely to have you in our little round here, but of course it's not possible to for everybody to travel to Hamburg to do this live. I have not so many questions yet, but actually a lot of praise. So personally, I find it great that you showed us a path from requirements, in your case job stories, to API and acceptance tests. And Robin said they love the idea of representing API usage as SMS messages between servers. And there's also some praise by JMS, who said he saw the approach work. And Jakob kind of had a praise and complaint in one statement. He said his reading list got longer again. So, by the way, for the audience, in case you haven't noticed, there are 2 API books in the Signature series, and they're actually complementary. So make use of this 35% discount code. I'll post it again in the chat in a couple of minutes, and then you can get both books and they complement each other. So let me quickly see if we have more questions for you. Well, more praise. There's a nice one. A technical question by Torsten. What role do you see for caching to avoid extraneous API calls to other services?
I do a few things. One is I teach people to first design the API. And by using ADDR, we can come up with an API profile that says, here are the operations we need, and then we can map it to our API style. And caching is going to vary by API style. GraphQL is a lot harder to cache on the client side because it's tunneling through HTTP. We don't get the benefit of being able to leverage middleware caching servers like we do with REST. So your caching will depend on whether you'll be able to do client side or server side and so on. But what I encourage is if you can get to this design, the other aspect is to understand some of the more complex, or not complex, but some of the other nuanced areas of HTTP. HTTP itself is an amazing protocol. It allows for evolution that a lot of other API design styles don't support. And so if you're going down a path where you're using a REST-based approach, or maybe it's an RPC, but it's over HTTP, and you're designating different URIs for each of your operations rather than just tunneling like GraphQL might, then you have this opportunity to introduce HTTP cache controls. So get your design first, then look for the opportunity using your API gateway logs, because of course you're going to put it behind a gateway to secure it, right? And you're not going to write your own authorization code because that's it's a lot of work, and it's can be dangerous if we can leverage somebody else's hard work instead, that's focused on it all the time. So if we have those elements, we can use our logs, see where the highest usage is, introduce caching, we can put in CDNs in front and everything else. And if we're looking at each operation and what we're trying to do, we're not going to be looking at just building anemic resources that deliver some data. We might have some pretty robust resources we return in some of these operations to satisfy the needs of getting those jobs done that we've identified. And at that point, then our caching really can be leveraged because we may have some pretty large, resource representations that we can cache by third parties and so on.
Thank you, James. So that was all the time we had. So thanks again, James, for getting up early and doing this. It was a pleasure to listen to your talk.